America is built on soft ground. Think about that for a moment. The places where Americans wanted to build, the places that mattered most, were the worst possible places to put anything heavy. River bottoms, tidal marshes, coastal mud, the banks of the Mississippi, where New Orleans needed wharves to handle cotton shipments from 1,000 plantations upriver. The edge of Lake Michigan, where Chicago needed a waterfront to receive grain from farms that stretched clear to the horizon. The Hudson River, where New York needed piers to handle the busiest port in the Western Hemisphere, ships arriving every hour from Europe and the Caribbean and everywhere else that mattered. All of it soft, all of it unstable, all of it seemingly impossible to build on. So how do you construct a bridge across a river when the riverbed is nothing but saturated mud 40 feet deep? How do you build a wharf that will hold thousands of tons of cargo when the ground beneath it has the consistency of cold oatmeal? How do you create the infrastructure of a growing nation when the very earth refuses to cooperate? You don't build on the mud, you drive through it. You take a log, sometimes 50 feet long, sharpen one end to a point, stand it upright in the muck, and hammer it straight down into the earth. You keep hammering until that log hits something solid, bedrock or hardpan or compacted gravel, something that won't move. Then you do it again and again, hundreds of times, thousands of times, tens of thousands of times, until you've created an artificial forest of timber columns beneath the water, a hidden foundation that will support whatever you need to build above. This is pile driving, and for 200 years it was one of the most essential, most dangerous, and most completely forgotten trades in American construction. The men who drove piles built this country's infrastructure from below. Every bridge you cross over soft ground, every pier you walk along, every waterfront warehouse in every coastal city stands on the work of pile drivers, and almost nobody remembers them. This is their story. Let's start with what they were actually facing. Picture yourself standing on the bank of the Ohio River in 1835. You're a civil engineer named William Foster, and the state of Pennsylvania has just awarded you a contract to build a bridge. Not just any bridge, a covered bridge spanning over 1,000 feet, connecting Pittsburgh to the communities on the far shore. This will be one of the longest bridges in America. It will carry wagons loaded with iron and coal. It will bear the weight of commerce and progress, and everything the young nation is becoming. The good news is that you know how to build bridges. You studied the best engineers in Europe. You understand trusses and arches and load distribution. The bad news is that the Ohio River at Pittsburgh has no bottom. Not really. The riverbed is alluvial mud, sediment deposited over thousands of years by the confluence of the Allegheny and Monongahela rivers. Silt and clay and organic matter layered 30, 40, 50 feet deep. If you tried to set a stone pier directly on that mud, it would sink. Slowly at first, then catastrophically, until your entire bridge collapsed into the water. You need to reach solid ground. And solid ground is somewhere between 30 and 50 feet below the riverbed. Invisible, unreachable by any ordinary means. The only way to get there is through the piles. Pile driving in 1835 was not complicated in concept. The basic technology had existed since Roman times. You take a heavy weight, called a ram, hoist it up above the pile, and drop it. The force drives the pile a few inches deeper into the ground. Then you hoist the ram again, drop it again, and repeat until the pile refuses to go any deeper. Until it's hit something that won't move. Simple, elegant, and agonizingly slow. The standard method for hoisting the ram was human muscle. You rigged a wooden frame over the pile, ran ropes through pulleys, and had crews of men pull to lift the weight. Each coordinated pull raised the ram a few feet. Then someone released a catch. The ram fell and struck the pile, and the whole process started over. A typical crew consisted of 12 to 20 men on the ropes, plus a foreman, plus laborers to handle the piles. On a good day, working from dawn to dusk, that crew could deliver perhaps 400 blows. A single pile, depending on soil conditions, might require anywhere from 200 to 1,000 blows to reach refusal. That means one pile per day was a realistic expectation. Now consider the scale of what William Foster needed to build in Pittsburgh. His bridge required 7 stone piers in the river. Each pier needed a foundation of timber piles driven into the mud, clustered together in groups, and capped with heavy timbers to create a platform solid enough to support masonry. The smallest piers required perhaps 40 piles each. The largest, the ones in the deepest water, required over 100. 7 piers, an average of 60 piles per pier. That's 420 piles minimum just for the foundations, just for the invisible part of the bridge that nobody crossing it would ever see or think about. At 1 pile per day, with 1 crew working, that's 420 working days, more than a full calendar year of continuous pile driving just to create the platforms for the actual construction to begin. And remember, you can't drive piles in the winter when the river freezes solid, and ice would crush any equipment left on the water. You can't drive them during spring floods when the river rises 20 feet above normal and the current would sweep away anything in its path. You can't drive them when it rains too hard because the men can't work in a downpour. You're looking at a working season of perhaps 6 months, maybe 7 if you're lucky. 2 years minimum just for the foundations. And that's assuming nothing goes wrong, assuming no piles split under the impact of the ram, which happened regularly, assuming no equipment breaks, no ropes fray and snap, no pulleys seize and lock, assuming no workers are killed or injured badly enough that the crew has to stand down while you find replacements. The cost was staggering. Pile driving crews commanded premium wages because the work was dangerous and demanded skill. A foreman might earn $3 a day in the 1830s, when a common laborer earned 75 cents. The men on the ropes earned $1 to $1.50. Good money for the era, dangerous money for the era. Multiply those wages by crews of 20 men, working for 2 years, and the labor costs alone approached $50,000. In 1835, $50,000 was a fortune. You could buy 100 acres of prime farmland for less than $5,000. You could build a substantial house for $2,000. The pile driving, the part of the bridge that nobody would ever see, the hidden foundation beneath the visible structure, cost more than many entire buildings standing on solid ground. And the worst part? Every other bridge builder in America faced the same problem. The nation was growing. Rivers needed crossing. The canals that had seemed so modern in the 1820s were being replaced by railroads, and railroads ran in straight lines, which meant they crossed rivers at whatever point the surveyors decided, rather than wherever the rivers were narrow or the ground was firm. Harbors needed piers to handle increasing trade. Cities needed waterfronts to connect to the commerce that was making America wealthy. And underneath all of it, beneath every ambition and every plan and every vision of progress, there was soft ground that had to be conquered before anything could be built. Something had to change. The old methods couldn't support the scale of what America wanted to become. That desperation created a market, and the market created machines. The first steam pile driver in America appeared in the 1840s. The exact date and location are disputed because several inventors were working on the problem simultaneously, in New York and Philadelphia and Boston. Each one convinced that applying steam power to pile driving would solve the problem that was holding back construction everywhere. But by 1845, steam-powered pile drivers were operating on construction sites from Portland, Maine to Galveston, Texas. The principle was straightforward. Instead of human muscle lifting the ram, a steam engine did the work. A boiler generated pressure. That pressure drove a piston. The piston lifted the ram through chains and pulleys, and a trip mechanism released the ram at the top of its stroke. No more 20 men straining on ropes, just the steady rhythm of the engine, the hiss of steam, and the regular percussion of iron striking wood. The early machines were crude. They broke down constantly. The boilers leaked. The chains snapped. But even the crudest steam pile driver could outwork 20 men on their best day. Here's why. A human crew could lift a ram 6 to 8 times per minute at a sustainable pace. A steam engine doesn't fatigue. It maintains the same pace hour after hour, as long as someone keeps feeding coal into the firebox. The smallest steam pile drivers could deliver 40 blows per minute, nearly 7 times faster than a human crew. The larger machines could deliver 60 blows per minute. Some of the massive drivers built for railroad construction could hit 80. A pile that took a human crew all day to drive could be completed in an hour. Steam pile drivers could also lift heavier rams. Human crews were limited to rams of 500 to 800 pounds. Steam changed everything. The early steam drivers used rams of 1,500 to 2,000 pounds. By the 1860s, rams of 3,000 pounds were common. The largest machines dropped rams weighing over 6,000 pounds. A heavier ram delivers more force to the pile. Piles that would have required 1,000 blows from a hand driver might need only 300 from a steam driver. One steam pile driver could accomplish in a week what had previously taken a month. The bridge builders of America suddenly had a tool that matched their ambitions. Let me tell you about Reuben Wells. Wells was a mechanical engineer from New Jersey who saw the potential in steam pile driving before most of his contemporaries understood what was coming. In 1852, while others were still debating whether steam power could really replace human muscle for this kind of work, he established the R.C. Wells Company in New York City, manufacturing pile drivers specifically designed for marine construction. His machines were elegant in their brutality. A cast iron frame, perhaps 30 feet tall, triangular in cross-section for stability, supported a vertical track called the leaders. The ram, a solid block of iron weighing 2,500 pounds, rode in those leaders like a piston in a cylinder, guided up and guided down, unable to move in any direction except straight up and straight down. A steam engine, compact and capable, sat at the base, connected to the lifting mechanism through heavy chains that ran over sheaves at the top of the frame. The operation required a crew of only 4 men, an engineer to manage the boiler and engine, to maintain pressure and adjust the throttle, a fireman to feed the coal, to stoke the fire, to haul ash and keep the water level right, a foreman to direct the work, to position the piles, to watch for problems, and a laborer to help position each pile and handle the rigging. 4 men doing the work that had required 20. 4 men accomplishing in a day what had previously taken a week. Wells sold his machines throughout the Northeast and along the Gulf Coast. By 1860, his pile drivers were pounding timber into the mud beneath wharves from Portland, Maine to Galveston, Texas. One of his machines, serial number 47, drove the piles for the Hoboken Ferry Terminal that connected New Jersey to Manhattan, creating the waterfront infrastructure that allowed commuters to flow between the cities that would eventually become the greatest metropolitan area in the nation. Another Wells machine worked the Chicago waterfront in 1856, helping to build the docks that would handle grain shipments from farms across Illinois and Indiana and Iowa. That waterfront would make Chicago the transportation hub of the continent. Without pile foundations, there would have been no docks. Without docks, no grain trade. Without the grain trade, no Chicago as we know it. But the real expansion of steam pile driving came with the railroads. In 1862, with the Civil War raging in the South, President Lincoln signed the Pacific Railroad Act, authorizing the construction of a transcontinental railroad. The Central Pacific would build east from Sacramento, climbing over the Sierra Nevada. The Union Pacific would build west from Omaha, crossing the Great Plains and the Rocky Mountains. Somewhere in between, they would meet, and the continent would be connected by rail for the first time. Both companies faced the same fundamental problem that had plagued William Foster in Pittsburgh 3 decades earlier. Rivers. Hundreds of rivers. The Platte, the North Platte, the Sweetwater, the Bear, the Weber, the Humboldt. Streams and creeks beyond counting. Nameless watercourses that appeared on no map but still had to be crossed. Each river needed a bridge. The railroads couldn't ford rivers the way wagons did. Trains ran on schedule. Each river crossing required a permanent bridge capable of handling the weight of locomotives and loaded cars. The Union Pacific alone would build more than 500 bridges and culverts in its first 7 years of construction. Many of those bridges required timber pile foundations driven into muddy river bottoms. The railroad couldn't wait 2 years per bridge. They couldn't even wait 2 months. The companies were racing each other, paid by the mile, and every day of delay cost money and political capital. Steam pile drivers became essential equipment for railroad construction, as important as the locomotives themselves. The machines traveled by rail themselves, mounted on flat cars that could be shunted onto sidings wherever a bridge was needed. A single pile driving outfit, what the railroaders called a pile driving train, could arrive at a bridge site in the morning, set up by noon, and be driving piles before sunset. A company named Naismith Wilson & Company out of Massachusetts specialized in railroad pile driving equipment. Their machines were lighter and more portable than the marine drivers used in harbor construction, designed to be assembled and disassembled quickly, moved from site to site as the tracks advanced westward. One of their pile drivers worked the Union Pacific line from 1866 to 1869, driving piles for 37 bridges across Nebraska and Wyoming. The crew who operated it, a foreman named Patrick Connolly, and 3 Irish immigrants whose names the records don't preserve, moved with the railroad like a traveling show, setting up and breaking down, always pushing west toward the meeting point with the Central Pacific. They became experts at reading soil conditions from the sound of the blow and the feel of the machine. Connolly could tell within the first 10 strokes whether a pile would reach refusal at 20 feet or 40, whether the ground beneath was clay or sand, whether there were boulders waiting to deflect the pile off vertical. He knew the difference between soil types by the pitch of the impact. A dull thud for clay, the mud absorbing the force without resistance. A sharper crack for gravel, each stone transmitting the vibration differently. A sort of singing ring when the pile tip hit rock, a sound that meant the job was almost done, that a few more blows would seat the pile firmly against something that wouldn't move. This was the skill that separated a pile driver operator from an ordinary workman. Anyone could run the engine. Anyone could pull the levers that lifted and dropped the ram. But reading the ground through the intermediary of 50 feet of timber required experience that took years to develop. The pile was like a probe, sending information up to the surface with every blow. The operator had to interpret that information, had to know what it meant, had to make adjustments based on signals that were invisible and intangible to anyone who hadn't spent years learning to feel them. The pile had to go straight down. A pile that went in at an angle was useless, worse than useless, because it would have to be pulled and the work done over. But the ground pushed back. Clay had a way of deflecting the pile to one side, the soft material flowing around the tip and pushing it off course. Buried boulders could kick the tip in unpredictable directions, sudden deflections that could ruin an hour of work in a single blow. The operator had to feel these deflections starting and adjust, sometimes adding guide timbers to straighten the pile, sometimes changing the angle of the leaders, tilting the entire frame to compensate for the ground's resistance, sometimes simply driving through with more force and hoping the pile would straighten itself as it went deeper into more uniform material. Connolly could feel a deflection developing when the pile had only moved a quarter inch off vertical. He'd signaled to stop, assess the situation, check the guides, make an adjustment, and resume. By the time he'd finished a bridge foundation, every pile stood within a half inch of plumb. That precision, invisible once the superstructure went up, made the difference between a bridge that lasted 50 years and one that failed in 10. But the skill didn't protect them from the danger. Nothing protected them from the danger. The physical danger of pile driving was constant and varied, arriving without warning from a dozen different directions. Steam engines operated under pressure. Boiler explosions were a regular feature of 19th century industrial life, and pile driving equipment was no exception. The boilers were built quickly to meet demand, built to price points that contractors would pay, built without the safety factors that modern engineering would require. A boiler explosion on a pile driver could kill everyone within 50 feet. The blast itself was devastating, a concussion that ruptured organs and threw bodies through the air. But the scalding steam was worse. Men survived the initial explosion only to die hours or days later from burns that covered their entire bodies, their skin sloughing off, their lungs seared by the superheated vapor they'd inhaled. Jacob Schroeder was 28 years old when the boiler on a pile driver exploded on the Erie Railroad Bridge project near Salamanca, New York, in August 1871. The blast threw him 30 feet into the water below. He survived the fall, but not the burns. According to the coroner's report, preserved in county records that I spent 2 days searching through, he lingered for 6 days before dying. His arms and chest and face were burned beyond recognition. He was conscious for most of it, the report says. Conscious and suffering. He left a wife named Margaret and 2 daughters in Buffalo, ages 3 and 5. The railroad sent Margaret $32, a month's wages. That was the extent of the compensation. That was what Jacob Schroeder's life was worth to the company that had killed him. The cables and chains that lifted the ram were under tremendous tension. Every cycle, thousands of pounds of force pulling against iron links that fatigued a little more with each repetition. When they failed, which happened regularly as metal crystallized and cracked from the constant stress, they whipped back with lethal force. A snapped cable could take a man's arm off, could cut him in half if he was standing in the wrong place at the wrong moment. Thomas Brennan, a pile driver foreman on the Illinois Central, died in exactly this manner in 1868. He was adjusting a guide timber, leaning in close to check whether the pile was tracking straight, when the lifting chain parted above him. The chain struck him across the neck and chest, nearly decapitating him according to witnesses. He was dead before he hit the ground. 41 years old, a veteran of the Mexican-American War who had survived Buena Vista and Cerro Gordo, only to be killed by a length of iron links on a peaceful riverbank in southern Illinois. He left a wife and 6 children. The company sent $5 for burial expenses. That was all. The piles themselves were dangerous. 50-foot logs of white oak or southern pine, each one weighing several hundred pounds, had to be wrestled into position beneath the leaders. A pile that slipped during placement could crush a man against the frame. A pile that kicked during driving, that jumped sideways from a deflection underground, could strike a worker standing too close. The underwater work might have been worst of all. In deep water construction, divers went down to prepare the riverbed for the piles. They worked in primitive diving suits. Canvas and rubber contraptions fed air through hoses from pumps on the surface. The suits leaked at every seam. The air hoses kinked and starved the diver of breath. The pumps failed without warning. Decompression sickness wasn't understood. Doctors didn't know that nitrogen dissolved in the blood under pressure. That coming up too quickly caused bubbles to form in joints and muscles and organs. Divers who worked too deep for too long experienced what they called the bends, a mysterious affliction that caused terrible joint pain, paralysis, and sometimes death. They didn't know the mechanism. They just knew that some men came up from deep dives and never walked right again. Some never walked at all. Some died within hours, their blood foaming with bubbles that blocked vessels and destroyed tissue. These were the men who built the Brooklyn waterfront. Between 1850 and 1880, the East River shore of Brooklyn transformed from a scattered collection of private docks into one of the busiest commercial waterfronts in America. The Atlantic Basin, the Erie Basin, Buttermilk Channel, Gowanus Bay. Hundreds of piers extending out into the harbor, each one resting on a forest of piles driven into the tidal mud. The Atlantic Dock Company alone drove over 8,000 piles in the construction of its facilities during the 1840s and 1850s. 8,000. The number is almost incomprehensible. Imagine 8,000 trees, each one 40 or 50 feet long, standing side by side in the mud beneath the water. That's what holds up a single dock complex. And that was just one company among dozens operating on the Brooklyn shore. I've searched the records for the names of the men who drove those piles. I've spent weeks in archives, turning pages of company ledgers and insurance records and newspaper morgues. What I found was mostly silence. The companies kept meticulous accounts of expenses, lumber costs, coal consumption, equipment maintenance, payments to contractors and suppliers. But the workers appear only as line items. Labor. So many dollars per day, so many days. No names, no individuals, just aggregate figures in columns of numbers. Occasionally a name surfaces. A coroner's inquest, required by law when a death occurred. A newspaper mention of an accident sensational enough to warrant a few lines of type. A petition for widows' benefits from a charity organization. Michael Flanagan appears in an 1856 coroner's report. Crushed between two piles on the Red Hook waterfront during the construction of a new pier. He was 34 years old, born in County Cork, Ireland, working to save enough money to bring his family over from the famine-stricken countryside. He never got the chance. His body was shipped back to a boarding house on Fulton Street, where the landlady arranged for burial in a potter's field, because there was no one to pay for a proper grave. His wife Mary received a letter 2 months later, delivered by a neighbor who had to read it to her because Mary couldn't read English. The letter explained that her husband was dead. It did not explain how, or why, or what she was supposed to do now with 3 children and no way to feed them. That's the pattern. The only time these workers become visible in the historical record is when they died. Their lives passed unnoticed. Their deaths merited a paragraph, a form filed with the county, a line item in an insurance ledger. We know more about the piles themselves than about the men who drove them. Consider this. Some of the timber piles driven into American riverbeds and harbors in the 19th century are still in service today, right now, as you listen to this. Wood driven below the permanent water table doesn't rot. There's no oxygen down there. No bacteria can survive to break down the cellulose. The logs simply sit there, decade after decade, century after century, supporting whatever was built on top of them. Engineers surveying bridge foundations have pulled up piles driven during the Civil War and found the wood still sound, still capable of bearing load. In some cases, the timber is in better condition than when it went in, compressed and hardened by generations of bearing weight. The grain tightened, the fibers strengthened by the pressure that tried to crush them. The foundations of old buildings along the Boston waterfront, structures built in the 1870s and 1880s, still rest on their original piles. New York, Philadelphia, Baltimore, New Orleans, San Francisco. Under the waterfronts of every major coastal city in America, there are forests of timber columns driven by men whose names we've lost. The men are gone. Their tools are gone. Even the companies that employed them have been dissolved and forgotten. But the piles remain. Those piles will likely outlast the buildings they support. When the structures above are torn down and replaced, when waterfronts are redeveloped and modernized, the foundations often remain. Why pull them? They're still good. They're still sound. Just cap them with concrete and build something new on top. The work of men who died 150 years ago, still bearing the weight of buildings that didn't exist when they swung their first hammer. It's a strange kind of immortality. The work survives even when the workers are forgotten. By 1880, pile driving had become an industry unto itself. Manufacturers like Vulcan Iron Works in Chicago, McKiernan Terry in New Jersey, and the Bay State Iron Company in Boston competed to build bigger and heavier machines. Patents were filed by the dozens. Improvements were made, tested, copied, improved again. A pile driver that would have seemed miraculous in 1840 was obsolete by 1890. The rams grew heavier. 3,000 pounds became 4,000, then 5,000. The biggest machines, the ones used for major bridge construction and deep water foundations, dropped rams weighing over 6 tons. Steam gave way to compressed air in some applications, then to diesel power in the 20th century. The technology changed constantly, each generation of machines more capable than the last. But the basic principle remained unchanged. Lift a heavy weight, drop it on a timber or steel pile, repeat until the pile hits something solid. The railroads alone drove millions of piles in the decades after the Civil War. Every bridge, every trestle, every culvert over soft ground required foundations. Cities grew on pile foundations. Chicago's waterfront was entirely artificial, created by driving piles into Lake Michigan and filling behind them to make new land, extending the shore outward into the water, creating ground where there had been only waves. Seattle did the same thing. San Francisco built over the tidal flats of Yerba Buena Cove, pile after pile after pile, until the water became solid ground and wharves lined a shore that nature had never intended. The World's Columbian Exposition in Chicago in 1893 required pile foundations for nearly every major building. The ground on the lakefront was too soft to support the grand structures the architects envisioned, the white palaces that would celebrate 400 years since Columbus. So pile drivers worked through 1891 and 1892, hammering thousands of timber columns into the mud. The White City rose on a hidden forest of oak and pine, magnificent above, invisible below. When that exposition closed, most of the buildings came down. They were never meant to be permanent, just a celebration that would last a season and then disappear. But the piles remained. They're still there, under what is now Jackson Park, under the Museum of Science and Industry, under soccer fields and walking paths and playgrounds where children run and shout without any idea what lies beneath their feet. Families picnic on grass that grows over the foundations of a vanished fair, and beneath the grass, the piles that men drove over 130 years ago continue holding everything up. I visited a working pile driver once, at a construction site in New Jersey, a new bridge going up over a tidal creek. The machine was modern, diesel-powered, nothing like the steam drivers of the 19th century. Computer controls monitored the operation. Safety cages protected the crew. Warning lights flashed and backup alarms beeped when the machine moved. But the principle was identical: a heavy weight riding in vertical tracks, lifted by hydraulic power instead of steam, dropped onto the head of a steel pile. The same basic action that pile drivers had performed for centuries, refined and modernized, but fundamentally unchanged. The noise was extraordinary. Not just loud, but physical, a presence in the air. You felt each blow in your chest before you heard it with your ears. A deep, percussive impact that seemed to shake the ground for hundreds of feet in every direction. I was standing behind a barrier 50 yards away, and I felt every strike in my bones. I watched the operator work. He sat in an enclosed cab, climate-controlled, protected from weather and debris, managing the controls with the casual ease of long practice. But I noticed his eyes never left the pile, and the gauge that showed how much each blow drove it deeper. He was reading the ground, just like Patrick Connolly had read the ground on the Union Pacific over 150 years ago. The technology had changed, but the skill was the same. When I asked him about it later, he said it was something you learned to feel. The way the machine moved when the pile was going in straight. The subtle change in the sound when you hit different soil layers. The moment when the pile started to refuse. When each blow drove it a little less than the one before. Approaching that point where driving it further would just damage the pile without making it any more secure. He'd been doing it for 23 years. His father had done it before him. His grandfather had run a pile driver on the Jersey Turnpike construction in the 1950s. 3 generations of men doing the same work, the same skill, the same trade. It was, he said, a good job if you could handle the noise and the cold and the traveling from site to site. You were always moving, always going where the work was, never settling down in one place for long. I asked if he thought about the men who had done this work before there were cabs and hydraulics and hearing protection, before OSHA regulations and safety equipment, before anyone cared whether pile drivers lived or died. He was quiet for a moment. Then he said he thought about them every time he set up on a river, looking across the water at some bridge or dock that had been there for 100 years. Somebody did this before me, he said. Somebody drove the piles that thing is standing on, with worse equipment and no safety gear, and companies that didn't give a damn about them. And it's still standing, he said. Whatever they went through, however hard it was, they did the work right. That's what matters. The work is still holding. That's the thing about pile driving. The evidence is everywhere, but invisible. Every time you drive across a bridge over a river, you're probably driving over pile foundations. Every time you walk along a waterfront pier, you're walking on piles driven decades or centuries ago by men who have been dust for generations. Every major building in every coastal city, every structure on soft ground anywhere in America, likely rests on timber or steel driven deep into the earth by machines and men you'll never see. We take it for granted. We assume the ground beneath us is solid, that bridges and buildings simply exist as if they grew there naturally, as if the rivers were always bridged and the shores were always lined with docks. We don't think about the work required to make soft ground buildable, but the pile drivers knew. The men who operated the machines understood that they were creating the foundation for everything that would come after. They were making it possible for cities to exist where nature had intended only marsh. They were defying the fundamental instability of the American landscape, driving timber and steel down through mud and silt until it found something solid, creating support where there had been none. The cost was high. The wages were modest. A few dollars a day for work that could kill you without warning. The recognition was minimal. No parades or monuments or grateful editorials in the newspapers. The dangers were constant. Boilers that could explode, cables that could snap, piles that could kick, diving suits that could leak. The men who died doing this work are largely forgotten, their names lost to time, their lives reduced to statistical entries in industrial accident reports. We know they existed because the work they did still stands, but we don't know who they were as individuals. We don't know their hopes or their fears, their families or their futures that were cut short. And yet the work itself endures. The Brooklyn waterfront that Michael Flanagan helped build is still there, still functioning. The piles he and his fellow workers drove still supporting tons of cargo and equipment more than 160 years later. The railroad bridges that Patrick Connolly's crew constructed still carry trains across rivers in the Midwest. The same foundations that were hammered into the mud before most of our grandparents were born. The foundations of the 1893 World's Fair still hold up the parkland of Chicago's South Side. Children playing over the work of men who died before their great-great-grandparents were born. That's the paradox of infrastructure work. The better it's done, the more invisible it becomes. A pile that's driven correctly never draws attention to itself. It simply sits there, beneath the water, beneath the ground, holding everything up in silence. Nobody notices because there's nothing to notice. The bridge doesn't sway. The building doesn't settle. The pier doesn't collapse. The only time pile work becomes visible is when it fails. And thanks to the skill and dedication of the men who did this work, failure was remarkably rare. We built a nation on their foundations, and those foundations held. So when you cross a bridge over soft ground, take a moment. Think about what's beneath you. Imagine the logs or steel beams extending down 40 or 50 feet through mud and silt and clay, finding purchase in something solid, bearing the weight of everything above. Think about the men who drove those piles, the noise they endured, so loud it left them deaf before they reached middle age, the danger they faced, from explosions and snapping cables and falling timber, and the mysterious sickness that came from working underwater, the skill they developed through years of practice, the ability to read the ground through 50 feet of wood, to feel when something was going wrong in time to prevent disaster. Think about the ones who died doing this work. Jacob Schroeder, who survived a boiler explosion only to die from burns over 6 agonizing days. Thomas Brennan, who survived a war only to be killed by a broken chain on a peaceful riverbank. Michael Flanagan, who came to America to build a new life and instead became a statistic in a coroner's report. Think about their families. The wives who waited for letters that would never bring good news. The children who grew up without fathers. The communities that absorbed these losses and moved on because there was no other choice. Because the work had to continue. Because the bridges had to be built. They built the foundation of America, literally. Everything that stands on soft ground stands on their work. Every bridge and every pier and every waterfront building. Every city that grew where the earth couldn't support so much as a cabin without help. And we drive past at 60 miles an hour, never giving them a thought. We walk along waterfronts and admire the views, without wondering what holds the ground beneath our feet. We assume that bridges exist and buildings stand because that's the natural order of things. It isn't. There's nothing natural about it. Every bit of it was made possible by men who drove timber into mud, who conquered soft ground through sheer stubborn force, who died in numbers we'll never know to build foundations we'll never see. That seems wrong to me. It seems like something worth correcting. It seems like the least we can do is remember. So here's to the pile drivers, the forgotten men who made it possible to build on impossible ground, the ones who pounded trees into mud so that cities could rise and bridges could span and commerce could flow and the nation could become what it became. We don't know their names, most of them anyway. We don't have their photographs. We don't have monuments to their memory. But we have their work. We stand on it every day. We drive over it and walk on it and build our lives on top of it without ever thinking about what holds it all up. And it holds. After all this time, after all these years, after everything that's been built on top of it, their work still holds. That's a legacy worth remembering. That's a debt worth acknowledging. The pile drivers of America, the men who gave us solid ground.